The first major problem that a new programmer will encounter is debugging. And you can't avoid it. You have to learn to master it. So whether or not you become a professional programmer largely depends on what your opinion of debugging is, because it will never stop. I know this stuff forward and backwards, and in a tutorial where I explain something simple, I will still have to stop and debug live in the middle of the tutorial because I typed something wrong just from fat-fingeredness. It's everywhere. It's forever. Get used to it. You have to master it, not avoid it. And the good news is Godot offers you some fairly typical staple setups specifically to help you master it. But I know that a lot of my audience are new coders, new programmers, and I want to make it clear what debugging is. Debugging is the final limit of your code. If you can't debug your code, it is dead. That's just all there is to it. And the issue is that debugging code takes more brain power than writing code. Because in order to write code, you have to know what every line of code is intended to do. But in order to debug code, you also have to know what every line of code could do wrong. And there are more things that can go wrong than go right. So obviously, it takes more brain power to debug rather than write code. And that's why every old programmer will tell you to keep things simple. Make sure your code is clean, make sure it's readable, make sure there's comments, because you'll come back to it in a month or a year, you will not remember a single thing, and you're still going to have to debug it, you're still going to have to refactor it, you're going to have to load all of these things back into your brain. What does this line do? What does that line do? Can I remember? This is absolutely critical, and it's even worse if you're working with other people's code. And you've got to load it into your brain for the first time because they're not using your thought processes. Their instincts are different than yours. So you're going to have to go through and figure out what they were trying to do and what they actually did and where the bugs are. If you cannot debug your code is dead. And here's where I need to get a little bit political. If you are using an LLM to write your code, goodbye, your code is dead. Feel free to argue about that if you'd like, but I'm just probably going to block you. I don't have any particular respect for people that use LLMs. I'm sorry you're addicted. Find help. You cannot maintain LLM code. You cannot debug it. You cannot refactor it because you will have to go back and understand what every line of code was supposed to be doing. And the LLM doesn't even know what it was supposed to be doing. The LLM does not have any intention. It just staples together similar strings of characters. So maybe the code works, maybe it doesn't, but it is DOA. If you are going to go back and try and fix it, you might as well have written it yourself because you're going to have to do the same amount of work to understand it in the first place. So please do not use LLMs to code or for any other reason for that matter. If that upsets you, feel free to leave. Now let's talk about the actual functions of Godot that will help you to debug your shit. The first and most obvious thing is the error message. In many cases, Godot will spit out an error message in some location, and that will tell you that something is wrong. This is obvious, right? But these error messages can pop up in a variety of places. They can pop up here, they can pop up here in output, they can pop up here in the debugger stack trace or in the debugger errors. Where they pop up depends on the kind of error you've got and whether or not you're trying to run the code. So you might have to look around just a little bit. If you get an error and you're not sure where the details are, it can be in a variety of places. Sometimes it even pops up right in the middle of the screen. But the good news about errors is that they are relatively easy to debug because they are the engine telling you that it does not understand what you were trying to do, and you should tell it to do that thing in a different way. And that's usually pretty easy to track down. Sometimes it's not, but usually it's pretty easy to track down. You just have to figure out what you did wrong. And in this case, some idiot typed a little asterisk right here. But the real difficulty comes from when there's no error message, but it's not doing the right thing. So the engine thinks it's doing the right thing, but it's not. That's when you have to try and figure out, well, what in my code could have caused this to not happen correctly? And that's when we start to gather information. Debugging is 5% having a mental model of what you think is going on, and 95% slamming data into that mental model until you figure out what's actually going on. So you need to keep gathering data to figure out what is the game engine doing that I don't realize it's doing. And the first step that everybody knows is the venerable print statement. Now, if you talk to coders, people are going to have a wide variety of opinions on print statements. For a while, it was the vogue to be strongly against them and say you shouldn't use print statements to debug. And I understand why. We'll get to why pretty soon here. But print statements have a lot of very powerful and valuable uses. The biggest use of a print statement is it leaves a log. This means that print statements can track state from frame to frame, from second to second, from menu to menu, and you can go back and look at what is actually happening over time. Now, there are other ways to track that. You can use like bar graphs and stuff. I'm not going to go over that sort of complicated stuff today, but print statements survive frame to frame. They survive over time because logs exist, and that can be absolutely invaluable if something is happening and you don't know exactly when or why. You can just keep printing stuff out, and eventually you'll see a value that doesn't seem right, and you can from there start to work out what to do. But as far as gathering information within a frame goes, the print statement loses fairly handily to one easy click. Wow, that was tough. This is a breakpoint. When we hit a breakpoint, execution stops. And this gives us a ton of information about what things actually are right now. The care name is actually the Frog King right now. The dialogue is actually Ubachaka, Ubachaka, Ubachaka right now. The character texture is this particular thing right now. And all of these things allow us to sort of get all of the data rather than just one little thing that we're printing out. See, we print out the dialogue here, but what if the problem isn't with the dialogue? What if the problem is with the care texture? What if we have an issue where this malfunctions, but only when there's no character texture? How can we figure that out? Well, we can investigate all of this stuff whenever we want. We can take a look at all the various values, and we can put breakpoints wherever we please, but we can also put a breakpoint inside of a conditional. If we're having a problem only when the character textures are malfunctioning, we can check if the character texture exists, and if it doesn't exist, we can break then and only then. The third one has no character texture. Now we know where the issue is. We can now investigate. Well, what's going on here? Well, this is the I Bet You're in Love with Me song. Maybe the problem is the musical notes. Maybe it doesn't know how to render the musical notes, something like that. We can start to track down what the problem might be. We're gathering data. And because we can see all of the data that's available by pausing the frame, we can do a lot of work on making sure that we can just check everything all at once. And the stack trace, is an amazing tool. So here we can actually go and see what's calling this. Okay, so we've got this at function ready, and we're paused right here. But what called at function ready? Why is this happening? Oh, it's here, add child inside of say. Well, what called say? Oh, it's right here. Well, what called that? Oh, it's up there. So we can continue to track it back as far as we would like. And that means that we can see what is calling the thing that is calling the thing that is calling the thing that is calling us. And that can be incredibly valuable. This also offers a number of additional tools in case you want to just check on a few more values. So for example, we can start to step here and we can start to continue here. So if we were over here in our dialog box and we want to see what's happening, we can just say, well, okay, why don't we continue on here? Now we're stuck here awaiting on DB tree exited. We can't really do anything else because we're just awaiting. So there's really no additional data going on here. We're just waiting until something happens. In this case, it's an animation. The animation completed. So now we're continuing. I would say that breakpoints are the #1 tool that a new dev should learn to love, because breakpoints give you access to so much information. And you can go backwards and forwards in your code, and you can try and figure out what's calling the thing that's giving you trouble. It's great. But it's not the only thing you can do. There are still other factors. One of the big issues you might run into, for example, is what if your breakpoints never break and your print statements never print because you never actually call that function? How can we see if we're trying to get something added to the screen and it never seems to get added to the screen? Can we take a peek? What's going on there? Well, the good news is that we have a couple of tools here. You might have noticed over here. Let's do that again. See this? This is what we've saved and we're working on. It's what gets compiled, but this is what's getting executed in the other window. And we can even take a peek. Here's our dialog text. Uba chaka, uba chaka, uba chaka. So we can actually just take a peek at what's actually running, what's in that window right now, and make sure that all the values are correct and everything that's supposed to be here, and everything that's supposed to be deleted is deleted. For example, you can see we have anim down here, but we don't have any audio. If we look at the local, we do have audio. So it's actually been deleted here. Did we intend that to happen? Well, yes. But if we didn't, we can try and figure out why it happened. This will really do wonders if you're trying to figure out why something exists or doesn't exist. And of course, you can also get values as to things like where the offsets are, what the transform is set up as. So if you've got UI that is randomly not showing up on your screen, it could be because it's at negative 12,000x, and you can find that out here. This is a really valuable set of tools. Now, if we want to go one step further, we can actually debug directly inside of this window by changing it from input to one of these other values. So in this case, we're using 2D, so we're going to do 2D. And this allows us to click on the nodes and get the data. Very interesting and valuable, right? But it's not the only thing we can do. We can also do showing a list of selectable nodes. So if, for example, we're having a time where you're supposed to be able to click, but for some reason it's not responding to your click, you can highlight wherever you're trying to click and you can see all of the things that might be able to catch that click. And you can check and make sure that all of those have their mouse set to pass or ignore or whatever. You can see what might be in the way. Similarly, you can always change whether or not you can see the visibility and whether you can select these groups and children and that sort of stuff. This is a very valuable tool for debugging what's going on. You can also change the playback rate, which is incredibly valuable. So if we want to go super slow just to see what's going on, we can change back over to input and click. Perfect. It's so nice. It is wonderful to be able to do this kind of stuff live and see what is happening and debug and see whether it's happening in the way you want it to happen. Those are the main tools that Godot offers to help you do debugging. Now there are a variety of more advanced tools here in the debugger menu, like visual profilers and video RAM and these sorts of things. You will need those eventually, but chances are if you need them, you will know you need them. You're not going to need the visual profiler for something like tracking down the UI is off screen. This is for when you're, for example, your processing is so slow and you're trying to figure out what's slowing down your processing. That's debugging at a different level. We're talking about the most basic logic debugging, right? So now let's talk about a couple of the more common kinds of infuriating things to debug. I would say that the thing that print excels at most is the kind of debugging that is the most obnoxious to do. So print might be a venerable and quite limited thing, but it has a few really nice features because of that log. Let me go ahead and show you. Here we have audio cue free. Let's put a breakpoint right here. There it is. If we look at the remote, the actual executing object, there's audio. Why is audio there? Didn't we delete it? Well, the issue is that we used the function cue free, which is what the game engine recommends you do. And what that does is it tells the game engine to clean that up and delete it in between frames. So the audio is still here. It's here until the start of next frame, basically. So if we have a situation where the engine is doing some kind of helpful cleanup, it can be so easy to have it happen between frames, which can be absolutely infuriating. Because how are you supposed to know when it's being deleted and what's going on? And well, you can just add print statements because it will log it. So if we were trying to track down when this audio is being deleted, we would be able to add something like a print statement here that would tell us that it's still there, or if it's still there, print audio is just deleted. That would help us track down what's going on. And we would see in the print logs, here's where we tried to access it later and it didn't work because it was deleted previously. And we could see that it was deleted previously in this here. And that's really valuable for us tracking down when the engine is being helpful. And that's one of the biggest challenges when you're trying to debug game engines, because game engines try to be as helpful as possible. They want you running at 60 frames a second. They want you not having any problems with RAM. So they are often very aggressive about optimizing things in ways you may not realize have been optimized. For example, leaving that audio there until the beginning of next frame, because it is far more efficient to delete it outside of the frame rendering buffer. So between frames, it gets deleted. That's all there is to it. But you, as a developer, might not realize that. And for me, that's when print is probably the most valuable. You are welcome to find another way to do that. If you find a great way to do that, let me know. I really haven't found one. But it is just a lot of fun to debug things. And if you don't agree, I'm afraid you're going to have a very rough time as a programmer. But I hope that this has allowed you some insight into how to take a closer look at the things that are causing you grief and kind of getting your mental model in conversation with what the game engine is saying is happening rather than what you are presuming is happening. That's it. Have a good one.